Well, hello.
Yeah, Angad, how are you?
Good. Good.
Good. Okay, so Angad, tell me one thing. Have you taken the physics before?
Yes, I have.
You have taken in the grade 11?
Yes, I've taken the physics. Yes, full physics.
Okay, full physics, right? All right. So what you have studied in that?
So I studied kinematics, energy,
Okay,
forces,
okay.
uh, electricity, and yeah, just kinematics, forces, electricity, projectile movement, and inertia.
Uh,
A lot of that. A lot. Both.
okay, the rotational. So basically, is it something related to the AP?
This year, kind of. This year I'll be doing the AP version. This
Okay,
year.
so the mechanics,
Yes, mainly mechanics and electricity and energy.
electricity and energy, which is also the
Oh,
magnetism, right?
yes, not magnetism, not fully magnetism, but electricity.
Only the electricity. Okay, okay. So that's good. That's good. This is going to help you in the NEET physics also because you are already having the physics background and AP physics is it's a good amount of physics in that and you have to study for that a lot also.
Yes.
So yeah, so definitely the school physics will work and here the thing is in the AP you are allowed to use the calculator, right? But here you are not allowed to use the calculator. That is the difference, right? So you will have to do all the calculation manually. You are solved by the end, right?
Okay.
So that is a yeah that is a big task, right? And second thing, the conceptual wise, it is both are exactly similar. Only the difficulty level of the question slightly higher in the NEET as compared to AP. Okay,
hmm,
all right. And yeah, one more thing in the NEET as compared to AP is that you have to memorize a lot of things, right? Here, like there is more or less kind of mugging up also. Yeah, right. So that we will do. Okay. So what I'm doing is I'm just taking a topic which is related to the mechanics itself, right? Because the mechanics has a huge weightage in the AP and as well as in the NEET. So what I'm gonna do is I will take a topic that is law of motion, right? In this we will talk about the Newton's law, the Newton's first law, second law, third law. Also we talk about the equilibrium, right? And also we will talk about the momentum also. You already have done it because the only thing which I have to check is how much you know, right? If you read, let's say, if you have not studied properly, then I have to teach all the things. If you are okay with that, then what I can do is we can directly start from the advanced level, right?
Uh, I think I know sound, harmonic motion, uh, momentum, energy, work, and forces, and like most mechanics and electricity. So anything about beyond that, like angular motion, I don't not familiar with. Not
All right.
like no angular motion.
All right. So I will start the rotational dynamics. Okay. So see, in the rotational dynamics, for example, if we are saying the object is moving in a linear, right? You can see the whiteboard, right? Uh, Angad, you can see the whiteboard, right?
Yes, I can.
Okay, okay. So let's say if any object is moving in a straight line, so let's say here is the one object that is starting with the velocity of v0 or v naught and reaches at the velocity of v in t seconds, right? In zero, at t is equal to zero, and at t equals to t. So that is displacing, let's say, delta x or just x, right? And acceleration is alpha, acceleration, let's say, a. So how can you define the displacement, velocity, and acceleration, Angad?
Displacement, velocity, acceleration. So first you have to determine the distance. of the A point A to B. Uh,
Hmm.
so first we need the distance before finding the displacement or velocity, which
Okay, okay. So the displacement basic, as in I'm asking in the terms of definition, right? So
uh,
displacement is how much it is moved from the starting position to the new, right?
yes,
Second, the velocity is the rate of change in the displacement, isn't it?
yes,
Right. Or we can say how fast an object is moving in a given direction. That is the velocity.
yes.
Third is the acceleration, how quickly
How
or by
quickly it
what
expands.
the how quickly the speed of the particle is changing, right? Right. Or we can say acceleration is just the rate of change in velocity, right? So then displacement here is the just the position, right? Change in position.
Yes,
Yeah. Velocity is the rate of change in velocity. Acceleration is the rate of change in. Okay. Displacement is rate of change in displacement. Velocity is rate of change in displacement. It is rate of change in velocity, right? Got it?
yes,
Okay. These are in the straight line motion. If you are talking about in the rotation, so then say one thing, the object has to move in the has to rotate about something, isn't it? For example, when we are using the screwdriver, so from point of contact it will rotate. If we are saying the clock, right? So from middle of that the clock will rotate, right? The this you know that uh, the needles will rotate, right? Isn't it? Or the second hand or hour end or minute end will rotate in that, right? In the clock.
yes.
So so then rotational dynamics, the something has to rotate. Something has to rotate about the axis. Rotate about an axis. Right. And if it is rotating, so that axis we will say this. Then here is the object that has got mass m and it is rotating like this. Right. So if it is rotating, isn't it? So let's say at t is equal to 0, at some time it will be here. It is displacing this much, right? It is
Yeah.
swapping this much, isn't it? So
Yep.
this angle is called the theta. That theta is the
This,
angular
yes.
displacement, right? So linear displacement, it goes from here to here. This is the displacement delta x, right? Angular displacement, how much it is starting from 0 and it will go till that.
360.
Yeah. So then angular displacement is the amount of angle swept. Right? Okay. Also, one more thing here. Let's say if any particle, for example, rotating clockwise or anti-clockwise, right? If any particle is rotating clockwise or anti-clockwise. So clockwise, we will say, let's say the pyridian, isn't it? Two pyridian, if it is rotating one circle clockwise. So it is going to be a 360 degree or two pyridians, isn't it? Right. So if
Yeah,
we
yeah.
are saying anti-clockwise, so anti-clockwise we will say negative two pyridian. Okay. So
Yes, yes.
clockwise, if you are taking positive, so anti-clockwise it's gonna be a negative. Okay. So that amount of angle it is swapping, right? Which is the angular displacement. Next is angular velocity. So angular velocity is the rate of change in angular displacement. Right. Velocity v, angular velocity, normal velocity we will say v, right? Acceleration a and displacement x. But here the angular velocity we will say omega. So omega, which will be delta theta divided by delta t, and that will be radian per second. So generally we will measure all these angles in the radians, right? Or omega will be d theta over dt as well. And this omega will be angular velocity. So by that, which is omega, right? So if the speed is constant, let's say something is moving. So for example, when we say the that eye, right? London eye or those, right? So in that there are the capsule which are rotating, right? So in those they will rotate with the constant speed, isn't it? So we will say their angular velocity will be fixed. So in the fixed amount of time they will cover the fixed amount of angle. So that angular velocity will be constant. But when you turn, let's say when you are turning on the fan or you're turning on the motor, right? A screwdriver, let's say the electric screwdriver. So their speed starts from zero, right, and reaches at the maximum, isn't it? So in that case, the angular velocity will be changing. So we will say there will be an angular acceleration. Okay. So when the particle is changing the angular velocity, so that will be there will be angular acceleration. Okay. So this is fine.
Oh yes, that's fine.
Right. So angular velocity displacement is how much the angular velocity is how much the displacement is changing over the time. Angular displacement is changing over the time. And angular acceleration, this is the rate of change in angular velocity. So if the particle is rotating, this is omega I, and here it is omega f, right? Or omega 0 or omega right? Initial. So omega I is the initial angular velocity. Omega f is the final angular velocity. So alpha will be Wf minus Wi divided by t, and that will be radian per second square. Okay, is this clear? This is clear. Okay, so you remember the motion equation for kinematics,
Yes,
Anjat?
yes.
So what are they? Can you please tell me very quickly?
Basic one is speed equals velocity equals distance delta d
Delta
over
delta t, right? Displacement over time. What for the
displacement
constant
over
acceleration? Yeah,
for constant acceleration. It's a change in velocity over time. Delta velocity over
yeah.
time.
His speed is equal to this.
Yeah, speed is
No,
equal
as
to
in I'm
distance
saying,
over time.
did you learn this? Did you learn
Uh,
this?
yes, I learned this.
Yes. That's how you learned, right?
What?
In this the way you are better.
Is that is distance equals velocity time and yes, I've learned that. I have seen. Yes, this is the way I learned.
Okay, all right. And S is equal to UT. Okay, so similarly, these equations, this equation only valid for constant acceleration. If there is no acceleration, right? No constant acceleration, then the velocity will not be a, then this equation will not be used. On and only for constant acceleration. So if we have the constant angular acceleration, right? So if we have the constant angular acceleration, then this you can see omega I has an analogy with the omega c. Right? Omega f has an analogy with the A is having the analogy, alpha is having the analogy with the X will be having the analogy with the Z, and T is the T. So that's these equations will be omega f will be omega I plus alpha T. Right? Omega f squared is equal to omega I squared plus 2 alpha x. X is omega I into T plus half alpha T squared. Look at this set of equations. They are same, right? They are same. They have the analogy. Only the difference is one is in the straight line motion, one is in the rotational motion, angular motion. So can you make a note of this equation?
Oh yes, I can write.
So, yeah. And mention that these are only valid for constant angular acceleration.
Okay.
Done, right? Yeah. Okay. Now see, if we are saying, suppose I will try to ask, I will try to recall something from the kinematic graphs. So if we are having a displacement time graph, right, this is for constant velocity, right?
Yep.
Constant velocity. So that means the gradient will tell us the velocity, isn't it? Gradient will tell us the velocity, right? And there is a no significance of area, right? So area. Okay. Is it fine?
Yes. Oh yeah. So yeah. Yeah.
Yeah. So then gradient is for velocity and no significance of area, right? And if we are having the velocity against time graph, so in this, the gradient will be velocity, gradient will be acceleration, and area will be change in displacement or distance traveled or distance. Okay.
Yep.
Okay. So similarly here, if you are having the t and theta, right? Angular displacement against time graph. So in this, you can see we can have this. So if t and the theta is not changing, let's say it's a 2 radian, right? At the 2 radian. So over the time it is at the mark of the 2 radian, right? So which means that the particle is not rotating. isn't it? You can see the particle may rotate. Particle is not rotating, may displace, right? We are not saying it is not rotating. We are not saying that it is not displacing. Remember that thing, right?
Mm-hmm.
Okay. And if you are saying if it's displacing, so if you are saying rotating, so may or may not displace, right? So both are the different things. So here the angular displacement is same, so that meaning is the particle is not rotating, right?
Mm-hmm.
And here you can see the slope is constant, right? And we know that the rate of change in angular displacement is the omega, right? Angular velocity, right? So here the slope is constant, so which means that gradient that tell us the angular velocity. Okay. So then omega, which will be also constant here. And here you can see the slope is getting bigger, right?
Yes.
Here the slope is getting bigger, so slope is getting steeper. And if slope is getting steeper, which means that it is increasing, right? So which is increasing. And if it is increasing, which means that the omega that is also increasing, can we say? So then the particle which is rotating, the particle has angular acceleration. Can we say it? Any problem of saying this? Angad?
Yes.
Yep. Okay. Let's say we are having the omega again t graph, right?
Yes.
So here is the t, here is the omega, right? The angular velocity against time graph. So in this, the gradient will tell us the angular acceleration, and the area will tell us the angular displacement. Okay. So gradient will be angular acceleration, and area will be the angular displacement. And if we are having the alpha against t graph, right? So in this, the area will tell us the change in angular displacement, change in angular velocity, not displacement. This is fine. Right? Make a note of this. Note down this very quickly.
Okay. 300. Is it C? C.
Yeah, 300.
Is
Once
it?
again,
Yeah. Is it 300?
angular displacement will raise. No, it's not, because
Oh.
see, it is starting from rest, right? So you have to use the equation.
Oh, wait. Yes. Hmm.
Omega is 0. No, alpha is not given, right? Only omega is 0. Omega f is 60. Right. T is fine. This. So 150 radian, right?
Oh.
This.
Okay.
Got it.
Yes.
Okay, you have to read it. You have to think about this question first before attempting, right? It's very easy, but you have to think it, right? Let's try it.
Which equation should I use here?
Yeah, you have to use the equation which we have done, but here is the rotation given, right? There are the 1200 revolution per minute, right? So here we can say omega I, right? 1200 divided by 60. So 20 rotation per second, right? And in the one rotation, how many radians it covers? 2 pi, right? So that will be a 40 pi radian per second. Similarly for this, and then you have to use alpha is equal to omega f minus omega I over t, or this. This is the hint. Can you try it now?
Yes.
Sorry. So see, this one we will convert into the radian, right? At the velocity. So 4,500 divided by 60 times 2 pi. Right.
Hmm.
So 150 pi. Right. So alpha will be omega f, so which is 150 pi minus 40 pi divided by t, which is 10, because in the 10 second, right? So 110 divided by 10 pi. So then see the pi's are roughly 3, right? So 3.1. So it will be roughly 30, right? You got the same answer, right?
How did you get the 150?
Yeah, here. This is 4,500 revolution per minute, right? So 4,500 times in one revolution 2 pi radians, and but we want in the second, right? So 0. So 0 0. This is 2 ones are 1, 2 threes are 6, 3 1, and this is 150, right? Isn't it? So 150 pi,
Okay.
isn't it? Okay, now try one more question. Can you please give a try to this? This is in this you also have to use the same um what do we say, the equations, right?
Okay.
Yes, Angat.
Uh, not sure.
See, so initially the wheel is in the rest, right? Right. So omega is 0, rotates with the constant angular alpha acceleration, so alpha, right? Rotates through the theta 1. So theta 1 in the first 1 second, right? And theta 2 in the next 1 second, right?
Okay.
Right. Right. So theta 1 will be, so then say theta is omega uh, t, omega I t plus 1 half alpha t square, right? So omega I, so which is omega is 0, right? So 1 half alpha t is 1 square. So 1 half alpha, right? And theta 2 will be, right? Theta 2, so they are saying in next 1 second, isn't it? So this theta 2, actually, in they are trying to say is from t is equal to 0 to t is equal to 1, right? So here is the theta 1. From t is equal to 1 to t is equal to 2, that is the theta 2. So they said through an addition angle of theta 2 in next 1 second, right? Right.
Mhm.
So then theta 1, theta 2. So, but if we are using the same equation, from that will be from 0 to 2 till that, right? So let's say this angular displacement is x. So x is 1 half alpha 2 square. So which is 2 alpha, right? But this x will be theta 1 plus theta 2, right? Isn't it?
Mhm.
So theta 1 is half alpha 3 over 2 alpha, right? The ratio will be half alpha and 3 over 2 other way around. Theta 2 over theta. So 3 over 2 alpha and 1 over 2 alpha, right? So this alpha alpha gone, 2 2 will be gone. So it will be just 3. So say, is it clear?
Uh, yeah, yeah, I think I see.
Yeah. Yeah. Can you please do it yourself again? So you will understand it how it has been done. Let's try it.
So,
Do it one
so
more.
every angle rotation is time. Every second.
Yeah.
Okay.
Yeah. Can you do it one more time to this?
Oh yes, I'll try. Yes.
Yeah.
Is it? I got a different answer. Is it? I,
See,
uh,
here they're saying as a part of maintenance inspection, right? The compressor and jet air was okay. So minute, right? The number of revolution made by the compressor. So this is omega, right? This is the omega and this is T. So area will be the number of revolutions
mhm,
because it's in the minutes, right? So just get the area and see how much you are getting. Just
mhm.
find out the area.
So the area, I checked the area and I added it. I got
Yeah,
wait, wait. I got 13500.
yeah. So 11250, right?
Mm,
Area of the trapezium, right?
yes.
Sum of the parallel sides times the height. So 2.5. So that this is 5. This is 2.5 and 3000, right? So it will be 1500 into 7.5. So which is 11,250. Okay, that's clear.
Yeah.
Okay, I'll give you one more questions. One more question. Yeah, done. What is the answer you got?
Uh, I'm conf which equation should I use for this?
So find out see, find the theta and divide by 2 pi. So you will get the number of revolution, right? Okay, use this.
I'm not sure.
Okay, they are showing the initial angular of speed of the rotating 24 this PM. So theta is um, omega I and alpha, right? Calculate how many full rotation and decelerates and comes to the rest, isn't it? So final will be 0. So then we can say omega final square, omega initial square plus 2 alpha theta. This is theta, right? And to get the number of rotation, that divided by 2 pi. Okay. This is the one thing. And second part, they're saying determine when the disk will stop rotating, right? So for that, what you have to do is you just have to find out, just use omega I plus omega I is equal to omega f is equal to omega I plus alpha t. Can you use this equation to find out the time? Because omega I you are having omega f you are having alpha you are having, and alpha should be negative because it's a deceleration, right? Yeah,
Yes.
yeah. Let's try that.
Okay, I'll try. -7. Is that the
Negative
answer?
7. Okay, one second. 24 0 is 24 minus 3 into t. 24 divided by 3. So 8 seconds. Okay, it will be 8 seconds. Yeah, look at this, Angad.
Yes.
Yeah. Okay, so it all this is clear to you, right, Angad?
Yeah.
Okay, but actually, you need a practice. You have to solve the questions. You are okay with the concept, but the thing which I am feeling that you have not done the enough practicing, right? For other kinematics also. Okay,
Okay.
thank, thank
Thank you.